So hi everybody. It's really nice to see you all together here at our first Scalus Club session. So welcome to the club.
First rule of the club is
yeah, somebody wrote, I think it was Giovanni. First rule of the club: tell everybody about the club. So just a brief history of the Scalus Club. It was meant as an idea for us. It's meant as a group or community of people who would start and work with us and pioneer Scalus development platform. And the goal for this was to really share with you the experimental features and ideas and involve you into knowledge sharing, some kind of ideas sharing, like receive feedback, learn from it, and as well learn from needs of this community and larger community about what capabilities are required for Cardano development experience. The Scalus Club consists of people who already use Scalus and for people who are interested in Scalus. And today is our first session. So I'm really happy to see the guys who are already in the club, but also people who joined for the first session just to see if it's something that will interest them. So just a matter of fact, we will be doing those sessions every 2 to 4 weeks. We're aiming for 2 weeks, but we'll see how it goes. You can subscribe at our Luma page. So you have a subscribe button, so you'll receive notifications for the new events. Also, you can join the club over here. Sorry, there is a button join, so you can you'll be receiving some notifications or kind of call for check or test of experimental features and so on. So welcome everybody. I will start, since it's our first session, and I don't know if everybody is familiar with Scalus. I would start with a short presentation of Scalus. So our vision and our goal for Scalus is to accelerate business and technological innovation on Cardano by speeding up development. So Scalus is an integrated end-to-end platform which helps engineers, R&D labs, but also businesses to develop everything that you want on Cardano. It consists of 3 blocks and solutions. So Scalus development platform allows you to write Cardano smart contracts. You can build off-chain like transaction in off-chain. You can evaluate transactions. You can build other elements and libraries. But also you can leverage JVM platform to build the backend applications with all what exists in JVM, in Java, and Scala, and other everything. Scalus is proud to be a development platform for 2 scaling solutions. So Hydrozoa, and the Hydrozoa team is here as well. And in the upcoming future, we'll be building as well Midgard node. Scalus leverages JVM for all off-chain application development. So you can use Scalus as a library in Java, Scala, and Kotlin. And the benefits for businesses and R&D lab is primarily threefold. It's acceleration and boosted productivity at scale with Scala 3. It's a reduced time to market with fast prototyping, which you can actually bring to production, and the wide deep pool of JVM developers available on the market, particularly in financial and fintech markets. Quick intro into our roadmap. So I don't know if you know, we have received the support from Cardano community with yearly budgeting, and the nature of this budget requires us to provide the milestone. So it's kind of we don't really enjoy fixing the milestones for ourselves, but we have to present it in a certain way. So we have 5 milestones. First is focused on adoption and onboarding. So we are right now in this milestone. Key elements in this milestone is improvement and tuning of smart contract syntax, and it's what we will be discussing today. Improvements of standard and test libraries, examples, various design patterns, and documentation. In the next milestone, we'll be working on ledger rules and conformal tests, JavaScript and TypeScript bindings, integration with mesh and Lucid evolution.
Just briefly, can I interrupt? Just wanted to mention that Scala has a capability and a compiler backend. It compiles to JavaScript, so all like almost all code in Scalus is compiled to JavaScript as well, and we export a JavaScript library that can evaluate smart contracts, do the budget calculation, stuff like that. That's why we have this JavaScript and TypeScript bindings element in our timeline.
In the third milestone, we'll be working on test capabilities. So we want to follow with development of our testing framework, and we want to leverage property-based testing like in a better way, even though it exists already today. We'll also provide the ledger rules framework that applications can use to build L2s, custom L2s, or custom decentralized applications. In fourth milestone, we'll be working on advanced UPLC optimization, so advanced optimization paths, Scala macros for UPLC code GAN, lowering algorithms, and so on. And then the final milestone, we'll be working on test data management and comprehensive CLI for everything you need to build, test, deploy smart contracts. I think one thing to mention is that we develop Scalus as a product. So those type of milestoning is not really natural to product development. So we want to mention that through conversation with you and also conversation with the other businesses who adopt Scalus, we'll learn what capabilities are required. So we are really able to reprioritize stuff and do things upfront if you need this or those capabilities. I think a good example would be working with Hydrozoa team, who has started using Scalus already maybe like 5 or 6 months ago. And we're really working head to head. I don't know how to say it in English, I think, where we discussing constantly like what capabilities are required, and we are trying to bring those as quickly as possible. So feel free today to share with us what are the interesting things or missing things that you think exist in Cardano development, and we'll try to address those in upcoming sprints. Sorry, moving forward. So today the session would be structured in this way. And so after a brief introduction, where we right now, we will go into a review session where we with our Lantern team will present you the 3 things, and I want to ask you to see it not as a presentation and an acceptance in certain way, but rather us sharing our work in progress and looking for your help to actually find the essence or the improvements or key functionality or capabilities that are required and simplify the life of developers on Cardano. So we'll cover three things: structuring smart contracts and how Scala language simplifies the development of Cardano smart contracts. Then our test approach with transactions and how we do debug in Scalus, and we'll briefly touch the performance of Scalus because it's a question that returns to us quite often, and through the lens of UPLC Cape submission. And there will be a couple of announcements at the end. So yeah. So before we start, so the goal of each review would be to share our progress, demonstrate capabilities, collect feedback, and learn. Each of the session will be structured like in 10 minutes demonstration and then like 10, 15, 20 minutes discussion where we can share the ideas and stuff. I will time box the demonstrations and the discussions, and I will activate the Q&A module, so you will be able to put your questions in that module. So it will be documented on one side, and then we can progressively answer those questions as we go. Before we start, do you have any questions about roadmap and about the club session? Feel free to ask. Okay. So then I would let's start with the first topic, structuring smart contracts in Scalus, and I'll let Sergey present.
Hey guys, I'm sorry. I'm gonna be taking over the screen sharing.
Yeah, let me start.
Boom.
Sharing.
Like Alexei has mentioned, we're going to talk about smart contracts and Scalus. But before that, if you're the kind of guy that would rather get some code in front of you to start playing around with it, editing it, whatever, you have two options. The first one is head over to scalus.org, which is our website. You can press the Get Started button, spend 2 minutes with this, and get some very basic but complete Scalus validator in front of you. I'm not going to go through the steps right now, but what you're going to end up with is something like that. This is option number one. Option number two, and this is what we're going to do with you today, is look at the Scalus examples, which are available also in our GitHub repo. Which is this. You can see here, there's a whole bunch of them. Yes, so with that out of the way, this is, well, I'm about to show you a Scalus validator. We're gonna go through this file and see how Scalus, my bad, allows you to write smart contracts and, you know, the bread and butter that you're definitely going to use when writing your own. So this is a file. This is a small exemplary, but a complete validator in just like 72 lines of Scala. First, let's go through the structure like very briefly. At the top, you see a bunch of Scala boilerplate, which is probably, you know, there's boilerplate at the top of every text file that is a program. Type definitions, and then the validator. Here are the type definitions, right? So for those, it would be useful to briefly mention that we're going to be looking at the hash time locked contract. I mean, for those unfamiliar, this is pretty simple. You lock the funds, and then whoever can submit a valid pre-image before time runs out gets to unlock the funds. Otherwise, the owner can get them back. And the types defined represent just that. You can see the pre-image, image, like what you would expect to see if you were programming it in any programming language. So before reading the code, I want to mention quickly the way that you actually do define your validators. Scalus exposes the type which all validators extend. Subtyping is a Scala feature, and we're using just that. We have the straight validator instead of Scalus prelude, and if you squint really hard, you're gonna see a lot of familiar stuff, because you're gonna see the methods that can be overwritten, which map one-to-one to Plutus. Basically to the intentions, right? The Plutus redeemer purposes. We have your spend, we have your mint, reward, certify vote, everything that you would want. Also keep in mind that, like Alexius mentioned, everything that I'm showing is a work in progress. So if you have any suggestions, if you have any thoughts, we'll be glad to hear those. So back to the HTLC. Also, I only have one screen, so whoever raises their hand, Alexi, please help me out.
Can you put your comment in the Q&A section or in the chat? And after the presentation, we'll have 15 minutes to discuss.
Yeah. So Alexi, please interrupt me if there's anything that I need to address.
Yeah, no worries. You can progress.
Right. Cool. Getting back to the HTLC validator. Here it is. As you can see, this validator only concerns itself with validating the spending of locked funds, and we override a respective method. If we were to also concern ourselves with minting policies, we would just override mint and do that. Also, hence the single validator can fulfill multiple roles by overriding multiple methods and thus be used in different contexts. So what you're seeing in front of yourself is just a 10-line long Scala function, which reads pretty neatly. And in front of you is basically what I've mentioned at the beginning. If we have a pre-image that we think hashes to the locked hash, we can present that, and otherwise, if we're the owner, we can time things out. This, in my opinion, really greatly showcases why Scala is a good choice of a programming language for any purpose, but especially for smart contracts. We can see that everything that you would want from a language, like for example, we have here your branching of behavior. Not only is it branching, it's also type safe, right? Because as you can see, the action, which is a redeemer type for this particular validator, is enum, which is a Scala keyword for types that have, I'm sure you're all familiar, but basically a type that has a known at compile time amount of variance to it. And as you can see,
think of them as algebraic data types. Yes.
Exactly. And this does just that. Sure, all of you with programming experiences are familiar with pattern matching, which it is. Also, every validator is at its heart a series of binary checks, right? Do we allow this action to happen or no? And this is neatly represented by a series of require statements, each of which takes a binary condition, and then if it's not satisfied, abrupts the execution with an error. Also worth mentioning that the require method, as you can see, is defined in the Scala standard library as an inline method, which basically means that the compiler will not generate a call here. We'll just stick the method body right into the code that we're going to compile, and thus opening the door for the meta programming capabilities, which Scala is very rich of. So yeah, this, I feel like it reads pretty close to English. Basically a very self-explanatory piece of code. Also, here you can see one other great feature of the Scala language that we also support is the fact that we can, one part is why it reads so well is because we can, Scala can allow you to add methods to any type that you would want. So if our standard library did not provide something on the transaction that you would want to use, something on any type that you can see here, and you wanted to add behavior, you would do this like this, thus enabling you to do the .autocomplete, which now knows that it can fill those in, right? Among the things that we've implemented ourselves in the standard library, you also have this, which I think enables, makes the whole thing more readable. Also, since Scala is an FP first language, we define pipes and all sorts of stuff, which you can access by reading our standard library more. And yeah, this is a validator. After you have defined a validator in Scalus, a validator is basically a piece of behavior, right? But the application, the distributed application that you might be writing, probably involves several validators, or perhaps it represents something more than a validator. This is a bit of a work in progress, but when implementing the support for blueprints, which is I think SIP 57 or something, we've started to think about the applications more in terms of like a collection of validators, more of like and this thing right here provides a like a bird's eye view of your entire thing. Also, while we've looked at Scala code, the logical question would be, how does it all get translated into UPLC such that we can stick it into transaction here? And this whole thing also answers that question. Basically, Scalus has ways to, well, we have a full compiler from Scala to UPLC. We can compile in different modes. This is just an overview of what is happening, but the code is open source, so feel free to read or ask questions. But basically, we can do this whole thing. Oops. My bad. Yes, and this basically has. I'm so sorry. Boom. Yeah, this basically allows you to get the hash of the script to stick it into a transaction, or we can also encode it using CBOR. And I think that's my timer. So I'm pretty sure Alex is going to take over from here to talk you through testing, talk you through this.
Yeah. But before that, maybe Alex, you can share like a few words about the vision for this element, like to complete what Sergey has said, and let's go into the questions.
Yeah, if you want, you can take over the screen share, Alex.
Yeah, no, just don't change anything. I'll talk about this quickly. So yeah, one of the benefits of using Scalus and Scala is that you have multiple levels in your single project. So you have your Scala code that is compiled to a script, and then you have this compiled script as a value in your program. It's very similar to how Plinth works. And you can leverage all these Scala capabilities like metaprogramming to generate your scripts, generate Scala code that will be compiled to UPLC, And then you can leverage Scala to transform that UPLC. So you can optimize it, you can transform it in any way. And then you can encode it in a CBOR and get it as a value in your program. And then you can use it in a transaction builder. And you can use it to generate a blueprint. So the idea behind this code essentially is to get this a wrapper on the validator code that can do all these operations and it will be well integrated with other pieces of Scalus. So you can get, again, from a code, you'll get the release and debug versions. So you can, for example, disable or enable login traces in your application. And you can use this in a transaction builder, and you can generate a blueprint to get it out in the world. Yeah, that's the idea behind this. We will probably improve it further and make it more type safe, but that's the rough idea, and
we'll show you the what is our progress on this in the next session.
Yeah.
Let's go to the questions. So I open the Q&A session. Yuri, you have the first question. Do you want to raise it yourself? Or?
Yeah, let me explain what I mean. So a script context is a pretty big type. It contains a lot, like just in case you need that information about transaction, about the purpose here and there, but not every validator needs everything, right?
Mm-hmm.
So I'm curious about your decoding strategy. Do you decode everything up front, and then, or you lazy decode only what you use? You got it.
Yeah, got it. Let me answer. So we have multiple backends. Essentially, currently we have 3 backends that compile. So we compile Scala to this intermediate representation called SIR, Scala's intermediate representation, and from which we can compile using different backends. Currently we have 3, and 2 of them compile the whole script context as Plinth used to do. I don't know how it works today. And we have a new backend that actually does it lazily. So it extracts values from script context by need, yeah, essentially lazy. Because also we have a special macros that can extract a single value from a script context. And sometimes, if you just look at one field in a script context, it's more beneficial to just take one field from a script context and use the other backend that generates the older backend, but it's going to be slightly better, because now today you need to look into which backend is better to use. But our aim is that we will combine those backends into one which will choose the best representation for you. So you would not need to worry about this at all.
Okay. Thank you. Rusty, it's your turn.
So I see you guys are defining the methods, like you have overriding the definition of spend right there. What is the default behavior? Because usually I deliberately leave out code if I don't want that path taken. Like if it's a spending script, I don't want it to be used for minting or staking. So I omit the code to keep the transaction size small, or the script size small. So what do you guys do there?
Fails by default.
Okay.
So if you don't override it, it's gonna fail on this script purpose, right? But by the way, you don't have to extend this validator. It's not the only way to write a validator. It's just the way we present you and recommend, but it's not obligatory. You can pass any function that takes data and returns unit. It would work as well. So you could write your own logic, whatever you like.
Our goal was to a bit abstract the user from low-level techniques and make it very simple for them to have something that is if you know Aiken, for example, you quickly recognize those script purposes.
Yeah. I must say that this is very, very similar to what Aiken offers now. They do basically the same thing. They offer you these predefined methods like spend, blah blah blah. We just basically copy it from Aiken because it's a good idea. Why not? But you don't have to use it again. So you have the full, but unlike Aiken, you have the full power here. You can do basically whatever you like. You can do like that, but also you can just pass your function. You can construct UPLC manually from terms, Peter, if that's your question.
Yeah. Wait. Have you answered your question, Rusty? Yeah. Cool. Peter.
Sergey, let me share the screen. So I'd like to present now.
You got it.
Peter, do you want me to read it for you, or you want to ask yourself?
Oh yeah. So I'm just wondering if we can run UPLC like inline from a script.
What do you mean? I'm not sure I understood.
So for instance, I know Phil DeSaro at some point was working with some people, and he had like a hyper optimized sorting function that was written in hand rolled UPLC.
Yeah.
And I know in Plutarch you could just sort of drop that in its encoded form and then call it within Plutarch validator. Do we have that capability in Scalus?
We can in Scalus we can just write terms almost manually. So we have like a DSL to do this. So here's a factorial example, which essentially copy of Plutarch implementation in the Cape benchmarks.
Yeah.
So yes, we can manually construct UPLC terms.
But what if we have already compiled stuff? Like, can we load UPLC from a file, deserialize it, and throw it in the same way?
Yes, absolutely.
Awesome.
Easy. It's just
Peter, I will note this for next time. We'll show it how to do it. Because
I can say that it is now in examples. If you look in the examples directory, you will find the example of loading external script.
Which example, Ruslan, do you remember?
let's maybe show it next time.
But it's
maybe
really trivial. Yes, it's super simple.
Great. Awesome. Thanks.
Yeah. Basically, what use case it enables, you can write or use smart contracts from, like, for example, from Aiken or Opshin, and then build all the rest of application in Scalus. So we're actually like having a use case, for example, for Hydrozoa, where like everything is written in Scala. We also have other cases where smart contracts are already developed. Just a backend, which is an off-chain, is written in Scalus. All right.
I'm showing right now, so you can load the program from a Seaborg hex, for example. So you just read it from whatever, and you get your program like that. And then you can p term, and you can use it whenever you want here. Done.
I just put a file with complete user icon test, where we have a smart contract developed by Icon and loaded in our machine.
Yeah. We do this. We can actually you can analyze other programs. So yeah, I sometimes load a validator and just, for example, run a statistics, how many built-ins were called, how much budget each built-in used, and stuff like that. So it's very useful sometimes.
Okay. Ilya, it's your next questions. Alice, can you show the code?
Is there a way to turn errors into an enum? I'm not sure I understand.
Yeah, can you elaborate?
Yes, sure. So I would imagine some cases when you want to pattern match over an error from a script or something like that within tests somewhere else. And the question is that now we tend to use just constants for errors, right? And the question is whether we can turn it into class hierarchy using an enum or traits or something like that to be able to put them all under one root, right? And the second question regarding, do we have an ability to print out, to trace values like integers or pi strings from our contracts?
Yes, let me start with the second one, and then I'll show the first one. So the question is about show, and unsurprisingly, there is a show trait. It's a type class, and we have show implementation for unit begin string boolean, and also for data. And everything anything you can translate to data, you can show it. So basically, what we can do log. We have a log function, which is essentially a built-in trace, right? And here you can do like true, then true, sorry, dot show. Then you can do like what else? What do we have? Redeemer dot show. So it's like that. That's an answer to the second question. And first one about the errors. So let me briefly state how we handle this. So in Scalus, we try to maintain the semantics of Java code, Scala code evaluation on JVM and UPLC. And in this way, we represent errors as thrown an exception. And whenever the exception is thrown, it compiles to UPLC error. But we special handle the parameter of an exception. And if it's a string, we'll log this, we trace log this string. So you can have a string. You see like this require method. What it does, if you take a look, it just, if it's false, it throws an exception requirement error and passes a message here. And whenever Scalus compiler sees this string message, it's gonna log it. And you can disable it. There is a flag in the compiler. You can disable logging of these messages. But if you throw an exception without a message, just something like that. Imagine you have like your custom blah 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 exception. It's gonna log the name of this exception, just a name. So you can have very like elaborate name explaining the exception, and it's gonna appear in the logs. And you can have a hierarchy of exceptions. So you can have something like class my exception extends exception class my other exception extends my exception, and stuff like that. And these names will appear in logs. And on the JVM, when you test on the JVM and you run your validator function as a Java function, you can catch those exceptions by type. You see?
Yes, I see. Okay.
Does that answer your question? Or?
Yes.
Cool.
All right. So next question is from Ganesh. Yeah, it will be we'll be touching. Let's park this question, and because we have a separate block about performance. And
but in one sentence, we can do anything that Plutarch, Plinth, or Aiken can do, because we have full control over generated UPLC.
And we'll show the details a bit later. So I'll leave this comment and we'll park it. Yeah, George. Okay.
Sorry, I'm late. For some
reason, no worries.
Not 10:30. Second, I think regarding the exceptions, there's maybe something even more that we can do, because I remember there was a trick that we used in the Haskell one. It used a template Haskell to kind of precompile sort of integer constants. We had all our exceptions numbered, right? And then we could turn them back into like the actual exception types. And in some cases, we even had not just like a plain like, oh, this type of exception happened, but we can also provided some arguments, right, that also got serialized and put into the trace. And then I think we were able to interpret out of the trace that particular error and turn it into an actual error type, like from the sum, right? And so when you run your, like when you try to validate with this on-chain code, what you would get back is, either like either everything worked, or you would get like this particular type of exception happened with these arguments and stuff. So yeah.
So we have like something similar to that. We have this abbreviate error traces class that allows you to extract all these error messages from a Scalus intermediate representation. And essentially, it's going to uniquely abbreviate the messages, and you get the map of the abbreviations to a full messages and vice versa. So what you can do, like you can in debug, you can have like the full messages, but on the release, you can have these abbreviate error traces pass and get the abbreviations, and then from this map you can extract the full messages in your tests or in your tools, whatever you like.
Yeah.
We have something.
One of the ideas that we had around these messages as well, and it's something still in discussion, we thought about maybe it would be useful to have a catalog of errors where you can yourself assign the code for error. I think it could be useful for protocol development or something like this, where you want to show
I think that would be a good idea, because that would help with stability, right? So you would know that, oh, I assigned this number to this error, and it will forever be assigned this number. Whereas if you automatically derive the numbers, if something changes, you might kind of lose that ordering.
Yeah,
right? So that's good. So I think that would in general be a good solution. Like in production, you only output you have the inline, just that unique integer or something that represents the error, right? But then in debug mode, you can actually have into the log, you output like the error type together with maybe some additional debug information like that corresponds to that error, right? That would be the best of both worlds, maybe. So
yeah, cool.
Yeah.
Okay, I put it into the list of things. Yeah, so we are about to go to the next session, which is testing with real transactions. Do you have any suggestions or ideas or something that you would love to see in future in Scalus smart contracts? Like if you remember something, just put it as a Q&A item, and we will just discuss it a bit later. Okay. So then I let Alex take over for testing with real transactions, and Alex will be talking. Let's talk about test strategies and our idea about how we can make it more like user-friendly and like business-facing.
Yep. So testing, it's very, very interesting topic, and there are multiple ways to do this, and there are multiple levels of testing. So the basic idea and what we have done until relatively recently, and I believe this is a common use case. I believe that's the default strategy for Aiken smart contracts, is your unit tests, your validators using script context. So you basically create script context by hand or generate it via property-based test, and you apply it to your validator and check the behavior. And we can do this, and we have tests like that. For example, Scala allows you to create this like a nice human readable expressions using infix operations. So this is actually a test case that constructs a script context, and then we just run it as a Java function and as a UPLC code, and check the results. But we tend to think that that's not the best approach, because so you tested your validator with script context. Then you need to create transactions that used your validator, right? And then you need to test that those transactions work using like local node or preprod or something like that. So you would need to like again test this, but with transactions. And another issue with the script context approach is that you can generate, I mean, you can produce script contexts that are not valid script context, which Cardano node will never construct. It cannot construct it by ledger rules, basically. So our thinking now is that we should rather test with transactions instead. So the idea is that you create your transactions and you immediately test your transaction building logic, and happy passes are tested with your transaction building code. And you can generate with property-based tests, for example, generate invalid or malicious transactions as well. And because we implemented ledger rules in Scalus, we can create the script context, same as Cardano node, from a transaction. So like you get a best of both worlds. You create a transaction that you can use. You test your transaction builder. From that transaction, you create a script context, and you can pass it to your validator as a JVM function, as a UPLC, on a UPLC, on a local node, or on a preprod. So let me quickly show you. So here's another smart contract. It's called Vault. It's essentially contract for keeping funds. You can deposit money there, and after some times, people who you trust can withdraw from this vault. And we have these tests. And the idea here is that you where is the deposit? For example, for the deposit, you use like a test wallet, and you use your transaction building logic to build a transaction. So let's check it out. So that's usually what you write as a backend. On a backend, you have a transaction building logic. So currently, let's take a look at deposit, for example. So this code creates a deposit. So we have a transaction builder that was developed by Hydrozoa team, by the way, thank you very much. And upstream to Scalus. So here's this transaction builder. You just spend a Vault UTXO. You pay to a script with a new added deposit, and from this you get a transaction, right? In a test, and we use this transaction in our tests. We call this run validator thing. And this run validator, it basically creates a script context from this transaction. So, and we just call this function as a Java function here. We just run this, and we run it as a UPLC. We run it on a CK machine. So this allows us to do a very cool thing. First of all, debugging in debugging smart contracts is a quite difficult task. In many cases, you know, that Ilya asked before how to do this show, how to log a value, because that's the common approach in validator development. Because I don't know, I know that Pi develops this this debugger, but I'm not sure how well it's integrated. I can tell you that in Scalus, you can just go to this deposit, just put a breakpoint here, and just run this in debug. And sorry, I need to import the show stuff. Oops, sorry. And I can just run it in debug mode, and I got a breakpoint here, and I can step here, and I can inspect values just right in IDEA. So I can get this out and see what's going on here. So this is like, I don't know, it's a next level thing for me. I developed this binocular thing when I need to parse Bitcoin block headers and calculate hashes, and without debugger, it could have been a nightmare, basically. So this is a very, very cool feature, and we maintain semantics between JVM evaluation and UPLC evaluation. So like in most cases, you can And in all cases, you can trust basically that if it works here, it would work on UPLC as well.
Sorry, what do you mean by UPLC evaluation?
I mean, we run this code, currently we run this code as a Java function, but we compile the same code to UPLC and run it in the CK machine.
Well, I guess maybe I ask it differently. Which CK machine implementation are you using to evaluate UPLC?
Oh, we implemented CK machine, of course.
Sorry, I missed that bit. So you have this steppable CK that's you use for.
No, we don't have steppable. It's just separate thing. We just use a debugger on a JVM and run it on a CK separately. So yeah, so we just leverage JVM for this. But also we run this on a CK machine, and this gives us the actual result. So we can check that the execution was successful, and we get the budget for this execution. And we get the budget within our tests, you know, so those are a value in our tests. So we can actually assert that our execution of our validator is within certain bounds. So you don't, so like, yeah, you see, so we can, yeah, we can check it here. What else? What else? What else I wanted to say? I think that's it, right?
Yeah, maybe I can jump in to sum up a little bit about the our testing strategy. So we see testing of smart contracts on 3 layers, let's say. So inside of your validator, you have some business logic. And for us, this business logic is tested with unit tests as a normal business logic, like in Scala. Or secondly, we have user actions, like individual actions that can be validated with a smart contract. So those we test with transaction, real transactions. So while we're building the validator, we're also able to directly construct the transactions that we will use with this contract, and leverage these transactions to test it on the level of on ScriptContexts with our ledger framework, which is incoming, with the help of YaCyDev tool for your DevNet, or also with pre-production overall. And then you have the third layer, which is more scenario testing, type of end-to-end testing, where you can execute the step-by-step scenario from beginning to the end of your successful, unsuccessful scenarios. So that would be a sequence of transactions. And today we'll not show it off, but our friends from Hydrozoa is building something really beautiful in it. So we will invite you guys to show us your magic, maybe in next or upcoming session of Scalus, if you don't mind, to show this kind of multi-step scenarios with a protection net and so on.
I recall that I wanted to sum up like the vision. So the idea, like what we are looking forward to, is to actually combine these approaches, like having this like a lightweight, a DSL-like test case description that would result in building transactions. Actually, so it's like think of it like a TX3 kind of DSL leash-like that allow you to generate test cases that build transactions, and with those transactions you can, depending on your environment setup, you can test either on JVM or on local CK machine, or on a local node like YaCyDev kit, or on a Preprod. So basically the idea is to get from a set of tests, like multi-transactional or just one transaction, you get the ability to test on different environments from the same code. That's the goal we would like to achieve.
Yeah, and so right now we have 2 ways to write tests. maybe Alex, can you show your screen? So we have this like more imperative way, like classical way.
Like here, right?
You're not sharing the screen.
Wow. Just did. Just a second.
Yeah. So just a general way. So you can write it in this way, or you can leverage this more like DSL type of testing. And for now, it looks like this, and we will be able to expand it with property-based testing. Like instead of putting like gives 100, you can gives x, and then you can iterate with various possible tests. And when Alex says that TX3, this really recalls the way how TX3 is building their transactions. So it's kind of a potential integration path for working with TX3 and using the same like general language to describe the transactions. So right now you have examples of both ways to write smart contracts. I'm sorry, test for smart contracts. I think that's it, what we wanted to share. What do you think? What do you think about the approach of testing the transactions with, testing smart contracts with transactions? And do you think that we are missing something? Because we really want to like use your kind of a fresh eye to identify if maybe we are missing something and maybe we should improve. Yeah, go ahead.
Yeah, so I wanted to say that in Hydrozoa we do generate our tests for the transactions, and as I asked in the Q&A section, in fact, when you build a transaction, you run the scripts, right? So that first part is kind of done automatically, and then we reuse, not reuse, but we just use validators, the rules that Scalus currently has to validate the transaction itself. And I think this approach is more or less similar to what you have.
Yes, one of the levels. I forgot to mention it, that we can run these transactions against a Scalus ledger rules. Those are Cardano ledger rules, but you can, yeah. Exactly.
Yeah, so in our case, we are kind of missing running the whole contract as a JVM function, right? We're just running it in the CRM script. Yeah, having all validators, you can verify that the transaction is really good for being submitted.
Yeah, and just to clarify, the reason why you run the CAK while building a transaction is because you need to run the scripts in order to balance the transaction. So if you've gotten to the balancing part of the transaction building experience, you automatically are running your scripts, because that's the only way you can find out how much you need to balance by, right? But that balancing doesn't actually run all the ledger rules, because not all ledger rules are involved in the balancing of a transaction, which is why we additionally then run all the ledger rules afterwards. But in fact, we don't actually necessarily need to run all the ledger rules, because in some cases, you're building a transaction that doesn't yet have the signatures, right? Because obviously you need to build a transaction first, and then you need to gather the signatures. It can't work the other way around. So in fact, the ledger rules that we are running are all the ledger rules except for the ones that have to do with signatures. And this is where some of the power of Scalus really begins to shine, because we can select which ledger rules we want to run and when we want to run them, right? In particular, the kind of the fancy advanced transaction building that we're doing in Hydrozoa, right, where we have like a chain of transactions, right? Within each chain, each individual transaction, also we need to figure out how much we can fit into it, because the rest will have to be handled by all the other transactions. So we're kind of incrementally growing it out of some pessimistic small core transaction that does as little as possible, and we try to cram more and more into it until we can't fit into more into that transaction. And that way, though we're planning to do it, we haven't started doing it exactly like that yet, but really all you need to do is just apply the transaction size validator, right, to this unbalanced transaction that you are progressively making bigger and bigger, until you realize that, okay, that last thing that you tried to put in is no longer fitting in. So just roll back to the previous, version of that transaction that you had, and that's basically your unbalanced transaction that you can then move on to, to balance and check all the other rules on, right? So this comes from the ability to select which ledger rules you run and when, right? This is a very powerful capability for transaction building that we're making use of and are planning to make even more use of in the future.
I just wanted to mention that the transactions and most of the objects in Scala are immutable objects, and it's very helpful in these sort of situations when you can easily roll back, just storing the previous state. You don't need to mutate any state for that. Yes, so the functional approach shines here. Yeah.
Yeah, Ganesh.
Hey, I had a quick question. I think you mentioned that we could do tests with Preprod network also. So I'm just trying to confirm. Will it be possible for me to let's say, extend these tests so that my transactions get submitted to the Preprod network?
Yes.
With the wallet that's on Preprod network. And I also want to ask, does that give me anything more in terms of completion of tests compared to just running it with the Scalus ledger?
Let me just first part of the question is that currently you would need to write a bit of manual code to actually run it on a preprod, but our goal is for you to be able to just by simply changing the environment to run those test cases on preprod or a local node or whatever. But currently you would need to change a few things. That's the first part, and the second part.
We have already the Yassi dev kit, and we can send it to local DevNet. So
we do this as well, yeah. And I think
maybe I will put it into the list. Maybe we can show how to do it next time when we will. Because we definitely have a code. We have a code to do that, so you can reuse it right now, and a bit later we'll just implement it into our simplified.
It's actually a part of Scalus starter project. There are examples of a transaction builder that runs on a local DevNet and preprod and and a node of University of Zurich as well, because I demoed it in Zurich, and they have their own Cardano network.
Yeah. And the reason why I asked it is such a feature can really help with the testing. So if I could do a new integration test directly connecting my Scalus tests to Preprod, that really avoids a lot of the manual testing that might have to go in when we deploy it for QA.
Yeah.
Absolutely.
Maybe mention, I think it's worth mentioning as well that while discussing with Hydrozoa team, we as well have seen the need of acceleration of testing. So that's why we have this ledger rule kind of layer where you can write a battery of real transaction and send them not to the real node, but send it to the ledger rules implementation of
and it's going to be thousands of transactions per second.
You do not quit the local environment, and you actually do not need to run a proper node to validate your transactions. So that accelerates dramatically your testing time. So you can start using this testing capabilities in your CI on every commute or whatever. You don't really need to have a real node in your testing at this testing layer.
Yeah.
If you want
can do this,
go to the next step, you can just make a selection of tests or set a scenario on the real node, but majority of the tests you can execute locally with just Scalus library.
Yep.
Yeah, I think this goes. This is a step in towards answering one of your questions, Ganesh, which was, what is the difference between testing purely in the ledger versus testing on a testnet, right? Like a preprod testnet. And the difference is that if you're testing purely on a ledger, you're testing just the ledger transitions, right? The transitions of ledger state. You're saying, here's a transaction, right? It's going to change the ledger state from this to this, right? And that's really all you're capable of testing if you're doing if you're just testing with ledger rules, right? So what you're missing is the consensus. Like, the testnet actually has a consensus running, and you have, potentially multiple people submitting transactions to the network, and then the consensus figures out which one wins out if there's any UTXO contention. Those sorts of things are things that you probably need some sort of a testnet with consensus to be able to test, right? You can sort of simulate it with a ledger-based one, but honestly, it's probably not worth it. You might as well just test it with with an actual testnet, which will give you the full range of randomness that can happen if you have to deal with consensus, right? In a ledger-based approach, you can maybe test something more deterministic, saying like, okay, I have this ledger state, and I have this actor who's submitting these transactions, but in between, I'm going to insert another transaction that is interfering, right? And then I want to see what happens if there is UTXO contention. And you can be very targeted about it. And actually, that can probably help you a lot with troubleshooting, because you can guarantee that, yes, this interfering transaction happened here because I actually inserted it here, right? So you can kind of do that. But you probably won't anticipate all the different ways in which various interference might happen on a real testnet. This is why testing on Preprod, for example, is still useful, even if you have the full capability of testing with a ledger, right? The other thing is the passage of time. So if you're just testing with a ledger, nothing is exogenously moving forward time. You're the only one who can actually affect the passage of time, right? So you basically have to figure out within your test scenario when you want the time to actually tick forward or not, right? Whereas on the testnet, that just happens automatically because it's a real consensus, and the participants in this consensus are the ones taking forward time. So again, it gives you more of that real life randomness of trying to interact with a distributed system, right? But it's still, it's nice to have the pure ledger testing environment, because it allows you to test as much as you need to test within that clean environment, and then just leave a small amount of testing left over for the messy, environment that has, networking and consensus in it, right?
Thanks, Josh. That makes sense.
Yeah. Any other questions, or we'll move forward to performance? Let's do it. I will just restart the timer, and we'll take over the presentation. Oops. Right. Yes. I think I will start with the presentation of the tool that Yuri is building with the help of Intersect and IUG and all other people who are interested in competing. In few words, or maybe Yuri want to present in a couple of words the tool.
Yeah, it's a good idea, since I'm going to give a presentation about the framework next week on the UPLC conference, so I might as well dry run in my speech, even though it's not finished. It's funny to see the picture that I generated with LLM, with the first version of Nana Banana, I think. CAPE is an acronym. It means, I invented it. It means Comparative Artifact Performance Evaluation. Like comparative meaning that we are comparing different ecosystems, or like compiler systems, different pipelines, comparing them against each other. Artifact, in this context, by artifact, I mean something that compiler has produced. Except that we're not testing blueprints here, but compiler is capable of also producing blueprints as artifacts. But in this case, you can read artifact as your UPLC program, like a validator. And it doesn't even matter in which encoding it is represented. What matters is like the meaning of your program, the structure of it. And performance, that's the tricky one. What do we mean when we say performance for programs? We probably don't mean like a wall clock time, like I'm waiting while it's running, even though it's important in the end. But here we can understand performance more broadly as in effectiveness. And there are particular measurements to that. Namely, you all are acquainted with the execution budget. It's the CPU units, memory units, and it has to do with the cost models that are protocol parameters. So the better execution budget you can have, the better performance, we say, your program has. But then not only, because there is other dimension called size of your program. And a size is also a bit tricky because we can measure size differently. We can measure size as in we serialize to flat CBOR and then measure size, like in terms of how many bits, in terms of the block space. And in the end, we pay for that. So it matters. Or size in terms of, I thought it could be useful in terms of the count of nodes in your, or like AST nodes, I mean, in your program, which is just a different angle at which you can look on at the size. So I believe these are like 4 foundational metrics that we are interested in optimizing. And Alex recently suggested.
Yeah, can I interrupt here? I just wanted to.
Right.
I want to speak a bit. Yeah, thank you for introduction.
Yeah, that was.
Yeah, maybe I think one other thing to mention is that we need to distinguish what are we testing, right? And like I think it started, and correct me if I'm wrong, as a similar implementation comparison, right? When you have the similar algorithm, and we are really checking what are the capabilities of compiler to produce the most effective code. Yeah, go ahead.
You're right on that. But it's not that we started and then moved to something else. Instead, it's twofold now. There are like 2 different use cases, 2 different personas that can benefit from it. And one use case, if you're a compiler author and you like developed your own compiler, you actually interested in measuring effectiveness of your compilation pipeline. So you fix the program that you're comparing against like as a constant, and you have everything else as your variable in your equation.
Absolutely.
And this is still there. And for that reason, we call this naive scenarios, like naive in the sense that we don't expect you to come up with a clever like optimization, whatever, memoization technique in the algorithm that you're compiling. Instead, we want your compiler to be as clever as possible while the algorithm is pretty dumb or naive. That's one mode, and it's there. And it's just a separate scenario that you can submit your benchmark against. Now, there is...
I'm showing
Right.
showing the current results, so you can find them by following this link.
This one is actually naive, the one that you showed.
Yeah.
It's the fixed, recursive, very naive algorithm of Fibonacci in this case. And we can see how different compilers out of the box, or maybe you can use a few flags inside your compiler, like erase traces, erase exceptions, whatever, aggressive optimizations. But yeah, so simply speaking, that's the idea. And I think it's still valuable, so it's gonna stay there. It's probably will stay at the level of this simple synthetic, like a micro benchmark. So it doesn't have to be like a real world representative validator, but it's something small and tiny, and it's like typical to use Fibonacci and factorial. And if you have your own algorithm that you think is a good idea, you can submit it. And then another mode, should I explain about that?
Yeah, sure.
It only became clear once people started submitting actual stuff that this is also something of interest. And actually, this is the place where this open for optimization mode, where people like compete most of all today. The idea there is that you can you have your own freedom choosing whatever implementation you want, and you can as well compete in choosing the very optimal or clever algorithm. Disclaimer, please don't cheat. So like, because you know the inputs upfront, secret, please don't hard code it, like what Volkswagen did, right?
Yeah.
Well, don't do that. They got a terrible fine. in the end, billions dollars.
Maybe I can jump in and say that we actually tried to delay our participation in this comparison stories because we have an adoption as a primary focus right now. But since this question was coming often to see, and I think Ganesh asked this question like at first 15 minutes of the presentation, we decided not only say that we are able to provide all the deep level optimizations and all the manual optimization paths like Plutarch is offering. We decided just to show it. So every time like somebody's submitting the thing, we just participate again, showing that this is also possible with Scalus. So at this graph, you can see that like through three graphs on the right, like Plutarch, Scalus, and I think Plinth will be there as well. Soon have literally the same performance.
It's a temporary state of things. It simply, for now, it means that those guys, they didn't take their turn. Like
yes, exactly. But Plutarch, for example, we're waiting for their prepacked version.
Yeah, it's going to be the same basically. So that's what I said. Like I don't know previously, that we are able to do everything, like in Plinth or in Plutarch, and more than in Aiken, I believe, because we have full control over the generated UPLC. And yeah, so here is the demonstration, and I can show you how we do this. It's relatively straightforward. Yeah, and other thing is that yeah, so I actually contacted Yuri and suggested to add a couple of you have the slide, awesome. Yeah. A couple of things because like measuring only budget and size does not show you the full picture, because like from a user's perspective or as a protocol author perspective, I'm more interested in what's going to be the fees. What are the fees? What's the actual cost of this? Because in UPLC, quite often, what happens is there is this we have a formula here, you know. So what fees are defined by memory, CPU, and the size of a script, and sometimes, and quite often actually, it is cheaper to produce a larger script and that will produce lower memory and CPU usage, because, for example, we inlined a loop, or because loops are expensive in UPLC for some weird reason. Yeah, so what people will do, they will inline loops quite often. And you get a big script, but it's going to be cheaper than running it using recursion. So
we're Lanter, we're like really business oriented. We are not like, we do not shy from technical competitions. So like, I think it's what you wanted to say, but Yuri, I think we would really happy that like if Cape can evolve in the direction of having this compiler competition to find that is a best baseline where everybody should kind of aim for. So we all together actually, and every tool can reach this level of baseline, so we can all together offer best level of performance for our users from different ecosystems. But the algorithm thing, we believe that it should not focus on synthetic tests, but rather go into direction of real business cases. And it's a harsh thing, because like we can imagine it as, for example, somebody from a business, I don't know, like who builds a liquidity pool, or market maker, or a protocol developer who would submit a challenge, and then companies who are interested in participate and apply their intelligence and knowledge of compilers or knowledge of algorithms or some techniques could actually come with ideas to how we can actually achieve this, and that will, I think, as a result, grow our general level of optimization. So
funny story.
We will be, let me just finish. Yeah, we will be kind of promoting this thing, And because of this, Alex contacted Yuri to speak about more like a business metrics that would be like used in those type of competitions, where we will really focus on what matters for users, how much it costs, like how much scripts like this we can enter in transactions, and so on. Let's Alex say a word, and then I will open the discussion session, and then we'll do not hesitate to put your kind of things into Q&A thing, and so we can just be more efficient.
Yeah, the funny story is basically that's exactly what happened like I don't know, a year ago. Mika from Butane Protocol made this like a bounty to create a smallest, simplest withdraw zero redirection script, which I wrote in Scalus using raw. Well, no, it's actually I used the compiler version, and I essentially won this small bounty competition. So like things like that. So like protocol developers produce like a challenge or bounty, well, not bounty, but challenge, and like different ecosystems can provide their solutions to this thing, and we can compare them by fees, by size. Yeah, so and it's beneficial, and it shows, and it's beneficial to the protocol developers, for example.
Yeah, Yuri, you were first to react. I'm sorry to interrupt you, because I wanted just to convey the thing. What was your reaction?
Yeah, this interesting phenomenon is this competition versus collaboration. In this open for optimization mode, what essentially is happening is that we collectively discover the equilibrium of what would be the most optimal approach to optimization of this particular scenario. I don't know if I'm breaking up, or is connection okay?
Yeah, you maybe disable.
We can hear you.
Yeah.
Right. Disable just okay. So what I already see happening is that someone like comes forward with, let's say, pre-packing some certain optimization that is effective. Like immediately authors from other ecosystems, they think, okay, maybe we should apply the same thing. In the end, everybody is applying the best performing optimization, and this is the process of knowledge dissemination. Like the best practice disseminates because there is an equilibrium, and we are collectively discovering it. The competition dynamics is just for you to have a motivation to contribute your submission, but the value that you reap from that is actually something else.
True.
Cool.
Yep.
George?
Yeah, I was just about to say that, actually. So all is fair in love, war, and on-chain code, right? There's no such thing as cheating, because if your real-life scenario says that, oh, I have these known inputs, right, then of course you're going to pre-package, because the size cost is much lower than the execution cost and so on. So I think this competition is revealing that for that particular scenario, these are the most optimal things. And then it just becomes a matter of like, well, how convenient is it to use a particular framework to reach that optimization, right? How much development effort are you spending to reach it, right? So that's the first thing I want to say. The second thing is, I think we should approach there's several different kinds of objectives that can be optimized here, right? So the main objective, and I think this has been the focus so far with the benchmarks, has been, what was it? Minimize, or you haven't really been measuring it this way, right? But you could think of a problem of, okay, the objective for a particular script could be to maximize how much it can do, right? How many, I don't know, how many DEX orders can you execute in the same transaction, for example, right? In which case, the objective function would be maximize the number of orders, right? Or what's the highest Fibonacci number that you can compute, given the constraints of CPU EX units must be within the constraints. Memory EX units must be within the constraints. The size of the transaction must be within the constraints, and also I guess you have to also constrain the fees, and or you could have like a weighted objective saying that this is the weight that I'm assigning to the number of DEX orders that this transaction is able to handle, right? Versus this is the weight that I'm assigning to the fee that this transaction ultimately reaches, right? And so you can calibrate those weights in a kind of multi-objective optimization, right?
Yep.
On the other hand, you could do a different kind of problem, right? You can set up the objective differently. You could say that, hey, I'm fixing the scale. I'm saying that, hey, in this particular scenario, I'm only interested in executing 3 DEX orders in a transaction. And what I'm more interested about is minimizing the fee and everything else to make it as cheap as possible. Because by my estimation, maybe executing 3 DEX orders in a single transaction is the most typical case, right? I don't know if this particular scenario matters for a DEX, but for another application, you probably want to be optimizing the fees for the most typical case, as opposed to these monster cases where you have to handle a bunch of things all at once, right?
Exactly.
Because that way, overall, right, if your low scale transactions are more optimal, overall you'll be saving more fees than if you have somehow some script that is optimal for like 100 or something, right? Like so we need different kinds of scenarios that have different kinds of objective functions defined for them, and it should always be a constrained objective, right? Because realistically, like we care about like these scripts actually potentially being used in real life, in which case they must fit into transactions, they must fit into blocks given the parameters, right? So it's always constrained optimization. You could maybe throw a couple of benchmarks that are unconstrained and just says, okay, percentage of budget, let's go like hardcore scaling. But those are more kind of theoretical and just like kind of academic curiosity based. But the ones that you want to be more relevant to real life, they always have to be constrained by the same thing that you would be constrained if you were to submit these transactions to on-chain, in which case you kind of have 2 main directions to go with objectives, either scaling or fee minimization given a fixed small scale.
That's exactly why I suggested to add exactly these 2 parameters to the K benchmarking, the fees and the percent of transaction execution budget.
But maybe like when somebody will present a challenge for the second category, we can actually define what are the constraints, as George saying. So like every other problem will have their specific, and I think that framework, as Yuri developed in it, actually offers combinations of those things. So we can maybe like discuss how that could evolve into like more business-oriented area. I want to answer the question from Matthew. Is that yes, there is one submission from Plinth. It's what is it? It's escrow, two-sided escrow, and we will be submitting as well our version just of basic implementation. I think in upcoming weeks we already have a version of it. Yeah. So maybe like when you guys have a discussion in next week on UPLC conference, maybe it would be nice to actually like agree with the community on what are the goals of each of the thing. And I think we will post a kind of a small message with our vision of things, which results in like, let's use like naive implementation as a baseline for compilers, so we can actually like streamline development of compilers towards certain targets. And this question of which language I use doesn't belong, because everybody are doing a great job in performing. And second one, just oriented more like business area. Matthew, did I answer your question, or you want to add something?
Yeah, I wanted to like make precisions on the question. Like the idea is just that evaluating Fibonacci is a simple use case, so it's good to have a baseline simple thing to compare different compilers. But the thing is, even some of the tests that you have in the Plutus pages, like the chess tests and things like that, like they don't make sense for actual contracts. And it's clear that Plutus initially was initialized with those tests because, for example, it influenced the way they initialize with the ScriptContexts, and that was one of the reasons why the the script initially couldn't run like Sunday could batch like 2 orders and not more, because the script context, the decoding was spending too much of the budget. So that's why I'm saying it's really, really, really important to focus on algorithmic, okay, but also actual use cases to see how different compilers like handle those, because eventually that's what's going on chain. That's what people are using.
Absolutely. I just wanted to mention 2 things. First of all, I just got my visa, so I'll be joining the UPLC conference in Edinburgh, hopefully, if everything goes well. And I wanted to make a talk there. I'm just writing to the guys. I just wanted to present a JIT compiler for UPLC, and probably not everyone knows about this, but we leverage Scala multi-stage metaprogramming to load UPLC in runtime and compile UPLC to Java code directly and run it on the JVM, and it runs like 8 to 10 times faster than on the CK machine. So like the idea, so basically lambdas compile to Java functions, applications to calls to functions, constants compiles to constants, and and built-ins compile to the actual implementations of built-ins. So essentially, we remove the CK machine and allow JVM to be the virtual machine. And JVM can compile the hot code to the machine code. So it's going to be very, very efficient. So it runs 8 to 10 times faster than CK machine, than Haskell CK machine. I mean, I just wanted to show you. So the idea is that there are some scripts. For example, if you run it on a L2 and you want to run them very fast, and you can compile and cache those scripts and run them basically as a machine code. I want to demonstrate it in Edinburgh. Yeah, and second thing is that our aim, like Alexei said, we have a special milestone for advanced optimizations, and we have the ideas with Ruslan, who is writing the backend for Scalus compiler. Yes, we have ideas how to do very interesting things and to produce optimal code with regards of fees and execution budget %. So what George were talking about, how to balance those things, we're gonna be working on in the near future.
Yeah. So stay tuned.
Stay tuned.
I will just jump into the last slide because we're running out of time. I'd like to close up with what's next. Announcement, we are releasing a new version today. There is plenty of interesting things in there, and everything that we have presented would be there. You can always use the ongoing development version. We're doing trunk-based development, so every day you have like at least maybe 2 or 3 commits in master, and the master is always almost always green. So you can take a snapshot version of the Scalus, and if you want to leverage the new experimental features, you can. Also, Catalyst 14 concluded last week. The results of the voting concluded, and so congratulations to Hydrozoa team, with whom we'll be collaborating on pilot readiness and new R&D. So yeah, if you are building any decentralized application which can profit from Hydro protocol, take a look at Hydrozoa. It leverages all Scala's platform to achieve its performance and coolness. And we're also in collaboration with with Fluid Tokens and ZK Fold will partner to build Bitcoin Cardano bridge called Bifrost. So as well, as a result, potentially all SPOs or like interested SPOs will be running the software written with Scalus platform. We invite you to try Scalus. Join our Discord, join our Scalus Club, and let's keep in touch in those. So yeah, next session in 2-3 weeks, we'll announce it separate. Yeah, it's what I wanted to say. And if you have any feedbacks or questions, let's have a couple of minutes for that.
Feedback. Thanks, guys, for all your brilliant ideas about the optimization. I think it's really cool.
Thank you for creating the benchmark. Yeah, and thank you for the by the way, Yuri made his first Scalus submission. So it's actually him who made the first submission. So he took Scalus, understood how to write a contract there and made it. It's quite impressive. Thank you. You're on.
Yeah, there were some comments. You feel free to share them.
Yeah, I just want to say one last thing is this compilation to machine code, right? It could actually lead to a very interesting sit, because in the future, perhaps Cardano itself could precompile some of the reference scripts, possibly for an extra fee, and then you could just have a built-in that says, evaluate this machine code that has already been precompiled, right? For much lower cost. Then you don't, because you don't have to interpret it via the CK machine, you can probably run these precompiled things just directly on the arguments. And then all you'd have to pay for is, you know, the deserialization of the script and deserialization of the, you know, redeemer and datum to feed to the script. But then the rest can operate on a completely different cost model. And for scripts that have to be evaluated very often, right? This could be a huge win for everybody involved, right? For the submitters who don't have to pay these huge fees, and also for Cardano, because precompiled just means that, you know, like the actual nodes use less machine resources physically, because they're running something that has already been precompiled and they don't have to do this clunky interpreter, right? Turing complete interpreter on these scripts.
Yep.
So.
Yep. And funny
there was a question from Matthew.
Yeah, that's good. Precompile is fine if you know you run what you run. Like Alex knows he runs his Scala VM and he can precompile to Scala VM. But
fair enough.
Running like maybe you can precompile to RISC-V or something like that, which is like
it's VM then. Anyways, you need to compile to machine code. The beauty of Scala's approach is
compile to all the architectures. I don't care. It's just a little bit of extra storage.
Yeah, so for us, it's simple. It's like, I don't know, the JIT compiler is like 100 lines of code or something like that. It's super, super simple. You just generate code that you generate Java, and JVM does the rest. It compiles it. So I don't need to, I don't care.
Not everyone wants to have the JVM installed on their computer, right?
Yeah, so what I'm saying is, yeah, at the end of the day, the cost might still be more worthwhile to compile to all the architectures that Cardano node is available on, right? Yeah. And just save that to the immutable blockchain, right? As you're in place of a reference script. And that might still be more effective than saving something that has to be interpreted.
Because of the cost modeling, it could be very tricky. There needs to be because it's a security feature, actually, right?
I know the cost model tries to abstract the machine wall time and so on, right? But still, I think it's worthwhile to explore, because the savings potentially, interpreted versus compiled always wins, right? So if fundamentally the purpose of the cost model is to be responsible with the machine resources that node operators have, right, and make sure that people can't exhaust them. Right. So if compiled is more efficient with those resources, then ultimately we need to find a way to allow compiled things to be run if they need to be run repeatedly. Right. Like if we start moving away from interpreted, it's going to be a better thing for the network overall.
So finally, Cardano node written in Scala, right?
Yeah, probably. GVM.
No way around.
Guys, it's already 6:15.
Yeah.
I think I will wrap up here. I'm really happy that you joined, and thank you for all this feedback. We'll be processing all of those. We'll post something as a follow-up. Feel free as well to share, like, if you want to see something else next time. We pretty happy to showcase any capability that you are interested in. So just make a request and we'll try to integrate it into our and if you think that there is something that would be really useful for development experience or like Cardano development, bring us those ideas and we'll try to prioritize them into our roadmap. Thank you for your time, and yeah, see you next time.
Thank you,
Thank
guys.
you.
Okay, guys. Bye.
Cheers.
Bye.